to get us going on it. All right, so first question, not too bad. Now, there is a nice little shortcut on this. The question says, before taxes are added, what's the sale price of the calculator? Well, if it's on sale at 20% below cost, right? Well, then they're selling it at 80%, right? So what some people do is they'll take 20% of the regular price and then subtract that. A slightly quicker way to do it, save you a few seconds, is to find 80%, because that's what we're selling it at. We're selling at 80%. And then please interrupt me at any moment on any of these questions as we go through them, all right? Question number 2, just substituting in values. Now, I did show all the math here. I mean, one of the big mistakes is forgetting that, we're subtracting G here, right? So there's a subtraction sign. And then remember, G is a -9, so right? So there's really 2 negatives. You're probably better off just typing into the calculator to make sure, because it's probably just as fast, because now you've got to do 19 times -5. And one thing I could have done was eliminated all these positive answers, because I know we must have a negative answer there. Question number 3 should be letter E. All right, we're trying to figure out what the outside angle is here. Well, we know that inside of a triangle, all the angles measure to be 180. So if I subtract these 2 angles from it, we'll have 30, which is here. Well, what's that angle going to be? 150. And then question number 4, we're just solving this problem. And when I glance at the answers, I notice, wow, there's a lot of fractions here. So I'm probably going to have to work it out. So I did, subtract 10 from both sides. And then to get rid of the 3/5, just multiply by the reciprocal, right? 5/3. That way the 3's cancel, and so do the 5's. And over here, you're left with 7 times 5 is 35 over, and this is really 7 over 1, right? So 1 times 3 is 3, and well, there's our answer, letter H.
I have a question on that one.
Yes.
Wouldn't, if you multiply by the reciprocal, it'd be a negative?
Well, okay, so I think what you're thinking also is when we're dealing with perpendicular lines, right? If one slope is 2/3, we say that okay, let me draw this a little better. These 2 lines appear to be perpendicular. If this slope is 2/3, we say this slope has to be -3/2. So in perpendicular lines, they have to be opposite reciprocals, right? Whereas here, if we did multiply by a -5/3, that'd make this answer negative, but then over here, this would become a negative x, right? And we would like a positive x instead. Did that help at all, or?
Wait, why would the x become negative?
All right, if you multiply, all right, so what you're saying is if we took this problem that we had, 3/5 x equals 7, right? And you multiplied by the negative reciprocal, is that what you did?
Yeah, because I always
Okay.
reciprocal is the complete opposite.
Okay, now if we do that, we're going to get -35/3 here. Now let's think about this. These cancel, right? Now when things cancel, a 1 goes in their place, really. So we've got a -1 times 1 is a -1, and then 1 times 1 is 1, and -1 over 1 is -1. And then what you have to do now is divide by a negative again. So reciprocals, like if I ask for the reciprocal of -2/3, you should say -3/2. All we're doing is we're making the denominator a numerator and the numerator a denominator. That's it.
Okay, got it. Thank you.
I'm thinking the stem of it comes from the geometry class where we've got 2 lines that are perpendicular, right? And we say do the negative reciprocals, and it kind of gets into people's heads that the reciprocal has to have the negative sign also.
Yeah, I think that's what I was thinking.
Okay, no worries.
Thank you.
That's why
no,
we're
that
here.
makes sense now.
Okay, good. 5 was a Pythagorean theorem question, and it was kind of terrible that it was not a Pythagorean triple. These are very rare. Notice I drew a triangle because I wanted to make sure I saw it better, because one of the mistakes is thinking a leg is a hypotenuse. They tell us a leg is 9, so I said this was 9, and another leg is 2. Notice I did not draw them to scale. They want to know how long the hypotenuse is. So I just did Pythagorean theorem. Okay. Remember, you always want to identify the letter C. What is the hypotenuse? It's X, so that goes over here. And then the two legs, well, they're on the other side. It doesn't matter which one's, which one's the A and which one's the B. You've got to make sure you know which one's the hypotenuse, which in this case is the letter X. Okay. Yeah, again, usually these are triples, and it's kind of rare to find one that's not. Question number 6 wants to know what's the probability the button is not white? Well, if you're not white, that means you're either blue or you are red, right? There's 3 red and 5 blue. So that would add up to be 8 out of the 18 total that there are. Don't see it there. But if we reduce that fraction, we do see that answer now. Okay, 7. 7's kind of, I don't know. It kind of goes against our grain because we really want to find X, Y, and Z. And the question just wants to know, what's the sum of 3 consecutive odd integers whose mean is 27? Now, what some people do is they see that word consecutive odd integer, and then they start thinking like, okay, I better do, X and X plus 2 and X plus 4, and really kind of get it to be too hard. All they're saying is that the mean is 27. So the way to find the mean is you add up the numbers, add up all 3 and divide by 3. Well, if I multiply both sides by 3, these 3's will cancel. And now we've got the sum, X plus Y plus Z. 27 times 3, 81. Again, it's a little discerning that it says consecutive odd integers, because sometimes that throws your head into a different frame of mind a bit. But in this one, since it says the mean is 27, think, oh, how do I find the mean? Add them up and divide by how many there are. Okay, 8, we've got to do 8 really by elimination, okay? The question says, which of the following values is a not possible sum for these two numbers? So they're spinning these spinners and seeing where it lands. Let's say we get a sum of 1, right? Well, we could land on the 1 and we could land on the 0 here, right? And 1 plus 0 is 1. So 1 does work. Then I try 4. Well, what could happen on 4? It could land on a 2 on here and then land on the 2 over here, because those would add up to be 4. Could we do a 6? Yes. Could land on the 4 and could land on the 2, because that would make 6. Could we get a 7? Sure. Sure we could. We could land on the 2 and land on the 5. Could we get an 8? There's no way to get an 8. So this one's really, I think, elimination. I think that's the quickest way to go. Okay, any questions on 1 through 8 at all? Okay. Question number 9. Okay, by the way, this test here was a bit of a stinker, I'll be honest. It was a rough one. Number 9 is telling us lots of distances between letters, right? Between numbers, between these different checkpoints. And for me, it was kind of hard to write it on this. So I just kind of straightened the road out and went from 1 to 5, right? And then I started putting the numbers in. Like they told us it's 6.6 between 1 and 3. So from 1 to 3 was 6.6. And then they tell us also it's 4.5 between 2 and 3. So from 2 to 3, I wrote down 4.5. And then they also say it is 9.7 between 2 and 5. So between 2 and 5, I wrote 9.7. The question says, how far is it from checkpoint 1 to checkpoint 5? From 1 to 5, this whole thing. Well, we know it's at least 9.7, right? Because that's like all of this except for this little distance. Well, this little distance is 2.1 because these two numbers, right? 6.6 is from 1 to 3. 4.5 is from 2 to 3. So the leftover is 2.1. 2.1 and 9.7 give us 11.8. Okay. Number 10 asks for the perimeter of the hexagon. So notice what I did. I drew a line segment here. And I'm like, okay, if this is 10, so is that, because they're both radii of a circle. I'm like, that looks equilateral, and it is. So if all sides are the same, we then know, actually, I take it back. All sides are the same, right? So this side is 10. So I'm like, well, how many sides are there? 1, 2, 3, 4, 5, 6. 6 times 10. Really quick. And again, remember, it is drawn to scale, okay? We could get into a bit of a rabbit hole of geometry proving that this is an equilateral triangle. But when you draw the line segment, it is. It is. Okay, 11. Okay, we're producing bats. We've got to write an equation or an inequality and solve it. Now, the question says it costs them $3,500 in overhead. So every time they operate, that's what they've got to pay, no matter what. Even if they make no bats at all, they still got to pay that. Well, it also costs them $2. I guess they're softballs. It also costs them $2 to make a softball. So the overhead cost plus $2 for every softball. Now it says, what's the maximum number of bats that can be produced for $15,000? So this amount here has got to be less than 15. Hey, have a good time. Has to be less than $15,000. So I solve it out. I get a nice number. There it is. Okay, 12 was interesting because they want to know what is x plus y, right? Well, over here on the left, we can solve for x, right? Normal algebra stuff. So x is 2/3. Ugh. I can solve for y here, doing normal stuff, and I get y equals -1/2. And so the question says, okay, better add those up. 2/3 plus a -1/2. I just use my calculator. I didn't want to feel like finding common denominators, which wouldn't be that bad to do, right? Because we know the common denominator would be a 6. And so I'd multiply this by 2s and get 4, 6. I'd multiply this by 3 and get -3, 6. Those add up to be 1, 6. But I really think using your calculator to add up those two fractions would be the fastest way to go by far. Anything yet to talk about so far? Okay. Let's look at the last one on this page anyway. The question says, as long as x doesn't equal 0, which of one of these expressions is equivalent to this? Wow. Well, it's kind of an algebra problem, right? Like I notice all my answers are not fractions. So in my head, I'm thinking, okay, this 5x has to cancel out. So in the numerator, I factored out a 5x out of everything. And then when I canceled the 5x's, this is where I wound up. Okay. 14 was just, the answer is K. So this is my arithmetic that I did to kind of go through it all. But really, you can't type it in your calculator and get it, right? Like here, -1 to the 3rd power is going to be a. Hey, did I lose connection with people there for a bit?
Yeah, at the end of 13, we just couldn't see what you were doing, but we
Okay.
heard you more or
right.
less.
God bless that spectrum. All right, well, let's try again here. Okay, so can you see my screen for 13? No, can you see 13 now on me or no? All right, let me try it one more time here. All right. Can you all see my screen?
Yes, we can.
Okay, thank you. Okay, so here was 13. And what we want to do is when I look at the answers, there's no fraction, right? Whereas in the problem there is. So that kind of clues me in that the 5x must cancel out. So if I try factoring a 5x out of the numerator, this is what I would have, right? Because remember, when you multiply, don't you add the powers, right? So x times x would have been that x squared there. And then when the 5x's cancel, well, yeah, 3x plus 5, which is letter C. And by the way, if you look at like which letters appear most frequently on the ACT for math, like I went through the last 10 years, okay, and I wrote down every single question's answer, and I charted which one happens the most often. They all happen the same amount of time. Okay, it's flat. It's not like letter A happens the most by far. Every answer here occurs within like a frequency of one. Like let's say letter B happens 12 times and an A might happen 13 times or 12 times. They're all between 12 and 13 answers. So anyway, I'm just saying, don't get all hung up on that. Okay, 14. 14 is just, you can use your calculator pretty quickly to get it, or just, be careful with your arithmetic. Arithmetic is tough. Like in this absolute value, I know it's -5, and I know -1 to the third power would be a -1. In the denominator, I multiply and divide first. I happen to see dividing first, so that's what I do first. I multiply, like if you think about that PEMDAS, right? PEMDAS, P-E. I wish people would write it out like this, where multiply and divide are on the same row. We multiply and divide at the same time. It just whatever we see first, like reading a book, going from left to right. In this case, I see dividing first. So 16 divided by 4 is what I have to do. And then I recopied the rest. And I keep on looking. The absolute value of -5 is 5. And then when I take 5 to the second power, I do get 25. Looking here, I'm going to multiply first before I subtract, which is an 8. Continue with it, and we wind up with an 8, letter K. Okay, number 15. Karen's invested $2,000 in a special savings account, and what's neat about it, and this is like, man, if someone ever could find one of these, it'd be the way to go. Every 5 years, the savings account will double. So there's a couple ways to do this. And the question says, how much will be in there after 40 years? Well, you kind of want to figure out how many times it will double, right? So if I took 40 years and divided by 5, because it doubles every 5 years, okay, I get 8. So the money is going to double 8 times. So one way to do it is to take 2,000 and multiply it by 2 times 2, multiply it by 2 8 times, right? Because when you multiply something by 2, it doubles. The other way to do it is to do 2,000 times 2 to the 8th power. And why did I not mark the answer on that one? 15 is letter D. It's not too bad. After 40 years, $2,000 becomes over half. Wow, that's pretty good. Let's keep going here. 16 is just asking a quick question. When will it remain constant? Now, constant means never changing, right? So if I'm looking at this graph, when does the graph never change? Right here. It's equal to 2, right? Equals 2, equals 2. The answer's never changing there. So that's what we say 2.
What was number 15?
Oh, I'm sorry. Number 15 is letter D. So we could have done it this way, right? Or we could have said, hey, there's 8 2s, so why not just do 2,000 times 2 to the 8th power, which would be a quicker way to go. But really, not such a big time saving here. I guess the mistake could be that you multiply by an extra 2 and get letter E, which would be not so good. Okay.
Thank you.
You're welcome. 17 is a really interesting probability question. I kind of translated a couple things here. It says, if it rains in Franklin City, so probability, so if it rains, right? So if it rains in Franklin City, the probability that it will rain the following day is 0.7. So I wrote that out. If it rained, probability that it'll rain the next day is 0.7. And then this one says, if it does not rain in Franklin City, so I wrote down, if it didn't rain, the probability that it will rain there the following day is 0.1. So if it did not rain, the probability it'll rain the next day is 0.1. lot of information there. And now the question asks this. Given that it rained in Franklin City on Monday, so that means we're looking here, right? Given that it rained, what is the probability that it will not rain on Tuesday? Well, the probability of it raining the next day there is 0.7. So of it not raining would be 0.3, letter B. Because remember, probabilities should always sum to 1.0, right? So this extra piece at the bottom here was just to try to confuse us a little bit. And usually they achieve what they're trying to do, right? We shouldn't even really look at that little piece there. We should just look at this piece. If it rained, the probability that it rains is 0.7. So therefore the probability that it would not rain the next day is 0.3. This math section, by the way, is almost on record of as being the most difficult math one that ever has been written. The 2016 December one was usually that held that honor, but this one was tougher. But good news, the tougher the test, the better the curve. So here's a question, number 18. What's the slope of the line but given by this equation? Now notice they got it to be 5x equals. I'll bet a lot of people did this. Divide by 5. And then that gives them x equals 9/5 y plus 18/5. And you might want to say the slope is 9/5, which we happen to see. But remember, it's got to be, y equals mx plus b, or as I wrote it down here, mx plus b equals a letter y. I could have gone that route too. And so that's what I did. I subtracted 18 from both sides of the equal sign. And then I divided both sides by 9. Now 5 divided by 9 is 5/9. Negative 18 divided by 9 is -2. So our slope is 5/9. Okay, 19 was pretty nice too. Given this one, I mean, it's kind of weird that 18 and 19 both are the same idea. They asked for which of these is the equation here. Well, this line's going down, so we know the slope is positive. So that's why I eliminated C, D, and E right off the bat. I'm like, can't be those. Now, I'm not going to bother with the slope because both of those have a slope of -2. However, the y-intercept is right here, and it's a 4. That's why it's letter B. A few people might try to say the y-intercept is 2, right? Remember, that's where it hits the x-axis. We're trying to find where we hit the y-axis, which is +4. Okay, let's do number 20 then. So this is the last one of those. Question just says, what's the value of x, which is right here. Now notice I went ahead and eliminated f and g because this angle is definitely bigger than 90. All right, I gotta go check my dog in a second. I'm gonna get you guys doing 2 problems now. So if that's 32, so is this one. These two should add up to be 180. Okay, if you would please, in your packet, I would like you to do 2 probability questions, 21 and 48. Okay, 21 is right after this, and then 48 is a little bit later in the packet. I'll be right back. So let's take 2 minutes on this one for timing. Go. Let's come up here then, okay? Okay, I've got about 1.5 minutes left here. Okay, let's take a look at 21 and 48. For 21, Now notice the question says drawn at random without replacement. So that means once we pull out that marble, it's out, it's not there anymore. I wrote down all the information that we had, and I wanted to know what's the probability of drawing a blue, then a green, then a blue again. Well, for blue, it's 4 out of 10, right? Because there's 4 blue out of a total of 10. When we go to draw the green, though, there's 2 green, but now there's only 9 left, right? Because we've got to marble out that blue one. Well, then we're going to go in and pull out another blue one. Well, we've pulled one out already, so now there's only 3 blue, and now there's only 8 marbles left. And what's helpful on this question also is if we glance at the answers, we can kind of see like what ACT is kind of looking for. Only takes a brief second to look at the answers. Definitely worthwhile. All right, let's look at number 48. Okay, 48 was another probability question, and I don't think we've done this one, but we may have. The question says they want to know what's the probability of A and B happening. Now remember, that means multiply them, right? Take probability of A times the probability of B. Now, we're supposed to subtract the overlap, but what's nice is it says, hey, these are independent events. They're not related to each other. So I'm just going to do probability of A times probability of B. There's the numbers, multiply them out is 0.08. It is letter F. Everybody, you want to lay on that? Okay, there's that one. Okay, let's do a domain and range question. We have not really done a whole lot of those. This is number 23 in your packet. Okay, question number 23. So I'll let you kind of, oh, God bless him. Take 30 seconds to work out 23. I'm just going to shut my door because he's just being a crazy puppy and no one's home. Okay, so the range is always what the answer is, right? Like we always talk about like X's domain, or we call it the input, right? And then the Y values are like the range or the output. In this case, we're saying F of X instead of the letter Y. No big deal. They want to know what's the range. Well, when I plug a -1 into this problem, that would be 5 minus 3 times -1. So 5 plus 3, which is an 8. So there needs to be an 8 for an answer, which eliminates E and eliminates A, right? Because both B, C, and D have an 8 for an answer. Let's try putting a 0 in. 0 is pretty quick. When I put a 0 in, the answer is just going to be 5. So I can eliminate this one. And then when I put a 2 in, that would be 5 minus 3 times 2, or 5 minus 6, which is -1. It's got to be letter E. So that one took a little bit. Okay, so domain and range. Oh, yeah, okay. Okay, number 47. A bit of a stinker, but not terrible. 47. It's way, 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 way towards the back. Okay. Man, 47. And we look at the question and then we look at the answer and you're like, whoa, we've got to rewrite these recursive formula as an explicit formula. What are you talking about? It's no big deal. Let's just write out the terms, right? A sub 1 means the first term. So the first term is 10, right? So I'm going to write that down, 10. That's the first term. So first term, second. I'm going to see if that maybe helps me see a pattern here. So I'm thinking I got to figure out a pattern. Now, to get A sub, the next one, let's say it's at A sub 2, right? Well, to get the A sub 2, it would be A sub 2 minus 1 plus 5. Well, 2 minus 1 is 1, right? So it's really A sub 1 plus 5. So it's really take this thing and add 5 to it. Okay, all right. If I want to figure out A sub 3, which is this one, I'd rewrite that formula. It'd be A sub 3 minus 1 and then plus 5. Well, A sub 3 minus 1, 3 minus 1 is 2. So it'd be A sub 2 plus 5. Well, there's A sub 2, which is 15. And we're just adding 5. So let's add 5 again. Looks like we're always going to be adding 5, right? Now, if we're always adding 5, isn't that a fancy way of saying the slope, the rate of change is 5, which allows me to eliminate a couple of these, right? Because A says -5. We're really adding 5. Now, now, a lot of people on this will pick letter C. Remember our formula, though. It's y equals mx plus b, right? The b value. And if I think about a graph, when something is graphed, the b value is when we touch the y-axis at. And that's got a location of 0, comma b. So I need to figure out the 0 term. So I need to go all the way back to the 0 term. Well, this has to be a 5, right? If we keep adding 5s. And then we get letter B. On this test, letter C was the most frequent one people picked if they didn't get letter B correct. Kind of a stinker, but again, towards the end of the test, right? So we should know that, you know what, they're going to have some tough ones in there. Okay. If you have your calculator with you, I'd like for you to get it out, because I want to look at this number 49. The question says, what's the solution set for that polynomial, right? Oh, he sees a squirrel out there, someone walking their dog. All right, so I want to find out the solution set for this. So here's what I do, okay? What I'm going to do is I'm going to go to y equals, and I'm going to go ahead and type this in, right? So x to the 4th plus 21 x squared minus 100. And then I'm just going to press Zoom standard, because I'm not sure what I was doing on my calculator before, but Zoom standard makes it go from -10 to +10, you know, all those nice things. Oh. Yes, Max, I will find one for you. Yes, 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 absolutely. So here's our graph. Now notice it touches at x equals 2 and x equals -2. Those are two answers that it touches at. And I think in terms of the solutions here, letter E is the only one. Answer has to be E. Now, I know some people like, Ms. Fine, I really like to see the factoring on this, because my teachers told me algebra is the way to go. I'm like, yes, algebra is definitely a good way to go on this, but sometimes it's much faster to use the calculator, right? If you do want to factor it, you could factor it, right? And then this side factors to be x plus 2 and x, well, with factors to be plus or minus 2. And over here, we can solve this side to be plus or minus 5i. But I really think the graphing is so much faster on that. Okay. Much faster.
How did you get those numbers through the calculator?
No problem. Were you able to type the function into y equals?
Yeah, I got the two
Okay.
lines, but I didn't know
Okay.
like.
So what I did was I looked at where this blue graph touches the x-axis. All right. Now there's a couple ways to do this. First off, I glanced at my answers here and I saw that they were all integers, right? Except for these imaginaries. If I'm not sure about reading this value as a +2 and a -2, what I could do is I could press second and choose table, right? By pressing the graph button. And then I could look and say, well, when do I have a 0 for an answer, right? I get a 0 at -2. And then I also get a 0 at +2. And so that tells me that -2 and +2 are a solution, right? Because this problem says, when does this thing equal 0? Well, it equals 0 when x is a 2 and when x is a -2. Does that help?
Yes, thank you.
You're very welcome. And then there's no need to proceed further. Well, actually, I take it back. That eliminates D, eliminates C, eliminates A, but it could be letter B. So, but I got rid of letter B because remember, I'm not sure if you know this or not, but the power, the highest degree, that's how many answers you should have. So since it's a fourth power, we should have 4 answers. So I guess we could have done that and eliminated A, B, and C because those only have 2 and 3 answers. Only the last 2 have 4 different answers. So yeah, that was good. Okay. I want to talk about a technique. It's question number 51, right? So number 51 here. Whoops, I went too far. Now, 51 is one of those questions that it's a big grouping, right? Like there's this whole page deals with this little bit of information here. This little bit of information we would use to figure out 50, 51, and then 52 on the next page. Well, for this 51 here, I think the best way to do it is to kind of do a bit of a guessing and checking on this one, instead of making a system of equations and getting all bogged down with that. Now it says this Skyline Tours, right, made $5,000 in one day by selling a total of 30 tickets for A, B, and C. So what I'm going to do is I'm going to write out those tickets, like we had C and A and B. And the thing is, it has to add up to be 30 tickets, right? That's what we're told. Now, it did say that they sold twice as many tickets for B as for A. So B is really going to be 2 times whatever A is, right? So let's say A is a 5, well, then B would have to be, well, 10, right? Now, they do ask, and we also want to kind of keep track of money as well. All right. So the question says, how many tickets were sold for tour C? Well, I'm going to guess, I'm just going to go ahead and guess 12. If we did 12 for C, right? What I would think of is, well, there's 30 tickets sold total, right? So if we had 30 tickets, I subtract 12 from that, that's going to give me 18 left for these two. So this would have to be, well, that's kind of tough, isn't it? I don't even think that's possible. No, I take it back. 18.
12 and
Yeah, we know it
6?
is. Yeah, 6 and 12, right? Okay, thank you. Yeah, so 6 and 12. And if I figure out the money for that, because in the reading earlier, they tell us how much money for a different tour it is. We would have 12 times the $200, right, for C, and then plus the 6 times $600, I mean, times $100 for A, and then we have to add in the 12 times the 125, right? Well, anyway, that winds up with 4,500. So we're like, C, no way. Let me try, so that was 12. Let's try 16 next. So if we did 16 here, right? Well, 30 subtract 16 is 14. This one, there is no way to do this, right? If I do 16 C's, there's no way to figure out A and B. There's no way for B to be twice as big as A. So let's try 18 next. If C is 18, well, 30 subtract 18 is a 12. And then 12 would be broken up to be 4 and an 8. That way those add up to be 30 like we needed to. And then, you know what? If we do the money, like we said over here, it's going to come out to be $5,000 like it's supposed to. And so our answer would be letter E. I know there's a system of equations that we could do, specifically since we know that, like if you want to see that system, what you could do is say we've got C here, right? We know that C plus, now these two combined, we know that A is an A, so A plus 2A is 3A. So we could simplify our math a little bit and just say C plus 3 times A is 30. But then again, the dollar values for B are different than the dollar values for A. So this one, it's something that we don't really do a lot of math class. We really don't do a lot of this making tables and guessing and checking, but remember ACT, they're supplying information for us. So we want to, figure out, use it for the better value for us, figure out what's going on. I do want to do a matrix question because we did one when we last met, and I kind of want to do another one here. And that's number 60 here. Okay, and it's the last question of the test, which is supposedly like the toughest question in the world. It's really not, okay? You just got to remember how to multiply matrices. To multiply matrices, we take this row and multiply it by this column. So I would say in my new matrix, it'd be 2 times A plus 4 times C. Now it's kind of awful that there's letters here, right? And then when I move over to the next column here, I move over to the next column and I'm gonna do the same thing. 2 times B plus 4 times D. And we continue with that idea. Now the thing is, once we had this piece here, and this is what happens a lot on the matrix questions, this is the only one with that piece there. We could have stopped after doing this row times this column. We could have stopped right there and been okay. Okay, Mr. Williams, are you there?
Yep.
Okay. I want to do one more and then I'm gonna stop and we're gonna get to reading and science here.
No rush.
Okay. 44 here is the one I want you to look at. And then everyone go ahead and just take 30 seconds and see what you can come up with. And by the way, Mr. Williams, the curve on this one for the math is the highest it's ever been. So it's like the toughest math section ever. I'm not sure how the reading compares, but in the English, but it was the toughest math part there was.
2 were hard, 2 were easy on the reading, I think.
Yeah. Does anyone have a way of rewriting this piece I'm putting in a box? Anyone have an idea? The key is the 7 right here.
A log base.
Oh yeah, we could. Oh yeah, definitely logs. Right there's a pre-calculus person for you right there. Let's go simpler though. Let's ignore logarithms and just think exponents.
49 to the 1/2.
Yeah, or just think about this. 49, isn't that, and this is the way ACT approaches it. Could we rewrite 49 as something to a power? We sure could. This is an A, okay? Isn't 7 squared the same thing as 49? And whenever I see something like this, I should try to do this. Okay, now when I do this, remember, power to a power we times, right? So 2 times A is 2A. And so now, since these are both 7s, it means both sides equal each other. Now this is 7 to the invisible 1 power. So that means that 2A has to equal 1 because 7 equals 7, right? So that means A equals 1/2, which I think is what you said earlier, right? 49 to the 1/2 power would be 7, right? That was a quicker way to go. But if I take this idea and apply it here, 3 to the A plus B, I need to rewrite 81 as 3 to a power. It would be 3 to the 4th power. And again, calculator is a beautiful thing on this, right? Try out a few numbers till you get it. Now, since these are equal, then we know that these must be equal. So A plus B must equal 4. Well, you know that A is 1/2. So that means that the B has to be 3.5, which is, of course, 7/2 on there. All right, the math on here is pretty challenging. It's pretty great, though. I would definitely, when we send the email out tonight, before you go to bed, take a look at some of these math ones worked out, okay? Because there's some real zingers in here, ones that we have not seen before. But overall, remember your techniques, right? Remember your Pythagorean triples. Remember to charge your calculator as soon as you're done, right? Plug it in and charge it all night long. Make sure it's charging. It'll show that it's charging. And if you don't have the charger, like yours uses batteries, put brand new batteries in tonight and then turn the calculator on. Some people will put the batteries in backwards and then the calculator, it does not turn on.